proceed with example number 3. And so first read what the question requires us to find. So find the area enclosed by the curve y equals x squared minus 1 and the x-axis. So again, every time when we are required to find the area enclosed by the curve, it's better for us to visualize the curve by sketching it. So we have a function y equals x squared minus 1. So if we were to draw the graph, it would look like this, with y-intercept at -1, because when we substitute x equals to 0, we'll get -1. So that is the y-intercept. Okay, and so it is bounded by the curve y equals x squared minus 1 and the x-axis. Okay, so what are the values here? So the values there will be the roots of the equation y equals x squared minus 1. So if we were to equate y equals to 0, then we'll get x squared minus 1. So x squared minus 1 is equals to 0. So x plus 1, x minus 1 is equals to 0. So this will be -1, this will be 1, because this one will be x equals to 1 and x is equals to -1. So these are the roots of the function. Okay, so now that we have already determined the boundaries, so if we were to highlight the boundaries, so this is the x-axis, so as required, this is the x-axis, and the other boundary will be at y equals x squared minus 1. So the function y equals x squared minus 1 will be the one I'm highlighting here. So now you can clearly see the area which we want to find. Okay, the area which is enclosed is the one that I am shading right now. Okay, so that area is the area that we want to find. Okay, so how do we go about finding it? To find the area enclosed by the curve and the x-axis, we would need to use our formula. So our formula to find the area enclosed by the curve and the x-axis would be area from a to b. So this will be the interval which we will be integrating, and then we take the upper function minus the lower function. Okay, and the whole thing integrate with respect to x, so put the x here. So this will be our formula. Okay, this formula has been used quite a number of times in the examples before, so by now you should be able to remember it. So let's see what we have here. So the interval would be from -1 to 1. And now what is our upper function and what is our lower function? So you have to determine your upper function. So now look at what you have sketched just now. So this will be your upper function. So this is at y equals to 0. So your upper function will be 0. Okay. And what about your lower function? So this right here is your lower function. So your upper function is equals to 0 and your lower function is equals to x squared minus 1. And the whole thing you would need to integrate with respect to x. So you put dx. Okay. So if you were to simplify it further, you'll get 1, -1 to 1, and this will be minus x squared plus 1. Okay, you open the bracket, you get negative x squared plus 1. So this will be dx. Okay, what you need to do now is just integrate as usual, and you'll get negative x to the power of 3 over 3 plus x from negative 1 to 1. Okay, and this is equals to negative 1 to the power of 3 plus 1 minus negative 1 3 power of 3 plus minus 1. So you'll get 2 over 3 from the first bracket minus negative 2 over 3. So when negative meets negative, you will add them up. So 2 over 3 plus 2 over 3. So this will be equals to 4 over 3. And don't forget, our unit will be unit squared. So this will be our answer. Okay? In this example, we are required to find the area enclosed by the curve y and the x-axis. So given to you the function y, so y is equals to x minus 2 x plus 3. If you were to expand it, you would eventually get x squared plus 3x minus 2x minus 6. So you'll get a cubic function. Okay, so you get, so this will be 6x. Okay, so the curve is a cubic function. Okay. So we are now going to sketch the cubic function and determine the region which we are going to find. So this is our x-axis and this is our y-axis. So if you were to look into the functions, okay, when we put y is equals to 0, so when we want to find the x-intercept of the function, we'll get x equals to 0, x is equals to negative 3, and x is equals to 2. So you would need to recall how to plot a cubic function. So because our coefficient of x cubed is positive, so the graph increases, decreases, touches 0, and increases again. So this will be your graph. So now if we were to highlight our boundaries, we will get, so this will be our first boundary. So we'll highlight it in, okay, we'll highlight it. So this will be our first boundary, the curve y. Okay, and our second boundary is the x-axis. So I will be highlighting it in red. So now you can actually see the area enclosed by the curve and also by the x-axis. So where is the area enclosed? So this is the area enclosed. Okay, the one that I'm shading right now. And the next area will be this part right here. Okay, so we've got two areas. So how do we go about finding them? Unlike the previous examples, we have two areas enclosed by the curve and also the x-axis. So I'm going to label it as A1 and also A2. Okay, so as you can see that both of these areas are actually region bounded by the curve and also the x-axis. So now what you need to do is you need to recall the formula on how to find the area of a region bounded by the curve and the x-axis. So if you remember, the formula would be from, formula of area would be from A to be the upper function minus the lower function, and you integrate them with respect to x. So you put here dx. So this is how you find the area. Okay, so for our case, we have got two areas now. So let us take a look at A1. Okay, if we were to look at A1, the upper function would be y equals x bracket x minus 2x plus 3. And what about the lower function? Okay, the one below it would be the one highlighted in red, which is y is equals to 0. And our interval would be from -3 up till 0. Okay, so I repeat, this will be our upper function and this is our lower function. And our interval would be from -3 to 0. So to find the area, we would need to take the integral of -3, 0, and the upper function would be x to the power of 3 plus x squared minus 6x. Okay, and our lower function is 0, so there's no need for us to write the lower function. So remember to write dx. And then we would need to add with A2. So this is for A1. Okay, so for A2, the upper function would be y equals to 0, and the lower function would be the curve function, so which is x in bracket x minus 2x plus 3. So what we need to do is we need to take the integral from 0 to 2. Why is it from 0 to 2? Because this is 0 and this is 2. Okay, we want to find the area of this region right here, which is bounded by this curve and also the x-axis. Okay, but the upper function is the x-axis, so y is equals to 0 at the x-axis. So 0 minus our curve function, which is x to the power of 3 plus x squared minus 6x. So this right here will be area for A2. Okay, so if we were to rewrite, we'll get 0, -3, x cubed plus x squared minus 6x dx plus 0 to minus x cubed plus x squared minus 6x dx. And we can eventually bring the minus out, so we'll get 0 minus 3 x to the power 3 plus x squared minus 6x dx minus 0 to 2 x cubed plus x squared minus 6x dx. Okay, so we can bring the negative out of the integral because this is one of the properties, because we can bring the constant out. So we are bringing -1 out, so it becomes these two integrals right here. Okay, so now when we integrate, we'll get x to the power 4 over 4 plus x cubed over 3 minus 6x squared over 2. So when you cancel this out, you'll get 3x squared. So we can straight away write it as 3x squared. 3x squared. Okay, so the interval is from -3, 0 minus x to the power 4, 4 plus x to the power of 3 over 3 minus 3x squared, because they are similar. Okay, so 0 to 2. So now, if we were to calculate this, we'll get 63 over 4 And if we were to calculate the second bracket, we'll get negative 16 over 3. So we continue. Okay, when negative meets negative, it becomes positive, so we'll get 63 over 4 plus 16 over 3. So this will give us 253 over 12. Remember the unit, it will be unit squared because we are currently finding the area. So this will be our final answer. To challenge your understanding on what we have learned just now, you can try these questions by yourselves.